learned another shortcut today. We learned AA last week. So this time we're going to do side, side, side.
Yeah.
Okay, do you remember that from when we did congruent triangles?
Yes, ma'am.
So what did it need to be for side, side, side? In order for all the...
Equal.
Okay, Josh is right. All the sides have to be equal. But this time we're not dealing with congruent triangles. We're doing similar triangles.
So like,
Yeah, Howie?
so I go sideways. Wouldn't you have to like do the ratio?
Mm-hmm.
Yeah,
That's exactly what we do. So side, 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 if all three pairs of sides are proportional, then the triangles are similar. Okay? So just like how he said, you have to check if all three sides are proportional, which means they all have the same ratio. Okay. So I'm going to move this up. I'll let you copy that down. And then we're going to look at an example here. They're going to ask you if two triangles are similar. Okay, so they could give you one triangle here, and then they could give you another one. Okay, so they'll give you two triangles, and in order to use the side, side, side to show that they're similar, you have to show that all three ratios are equal. Yeah, Holly?
So wouldn't it be like, wouldn't it be like 12 to like AB over DF, which is 12 over 8, and then it would be AC 18, and then D which is 12, and then BC which is 15 over FE which is 10.
That's right, so you have to match up the corresponding sides. Now sometimes they try to trick you and they'll try to turn one of the triangles, flip it over. So the easiest way to do it, instead of like saying, oh, well that matches up with there because it looks like where it's supposed to be, you look at the side. So here, what's the smallest side?
12.
12. And what's the smallest side of the other triangle?
8.
8. So that's how you can match up with smallest triangle. Smallest side with smallest side, medium side with medium side, largest side with largest side. So what's the medium side here?
15.
And then here?
10.
Okay, and then the last one is
18 over 12.
Yeah.
So we have to check, are all three of these equal? Now all three of them have to be
Reduced.
equal
Can they
for
be
them
reduced?
to be similar. If only two of them were, and the third one doesn't, then they're not similar.
Wouldn't that be, if you reduce 12 over 8, wouldn't that be 3 over 2? Yeah, 3 over 2.
3 over 2?
Yeah.
And you can always put this in your calculator, use that ABC button. So 12 over 8 reduces to 3 over 2.
And
Yes?
then 5,
Use 3 over 2.
yeah, 5, 10 is 3 over 2, and then 12, 8 is 3 over 2.
So yes.
So yes.
So yeah, so all three of them are equal. So then, yes.
So yes by yes by side side.
By exercise.
Yes by side, side, side. Now, they might ask you for a similarity statement
Then
with the squiggle.
yeah, it would be
Okay.
wouldn't it
They
be
sound
A B
equal.
C?
So, yeah.
So can someone else tell us what the similar statement would be?
It would be
Yes, Josh?
ABC is similar to,
ABC is similar to what?
yeah,
D, D, E, F?
no, DF.
D, F, E. Okay. Make sense? Any questions, comments, concerns? Can I move on?
Yeah.
Okay, let's try another example. Let's call this example 2. So we're going to see, are the triangles similar? are these two triangles similar? I'm going to draw them here. Okay, so let's get that down in your notes. We have two triangles here, and we want to tell if they're similar. So we have 12, 5, and 13 on one triangle, and then 12, 9, and 15. So we have three sides, so we might use side, 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 but we gotta check if the sides are proportional. So, does anyone set up that proportion for us? Yeah, Brandon?
12 over 12, 15 over 13, and
13?
9 over 5.
And what?
And 9 over 5.
And we want to check is 9 over 5.
And it's not proportional.
Okay. So we know 12 over 12, that's 1. 15 over 13, I don't think that reduces.
No.
So you can erase, stop right there. Wait, two of them aren't proportional, so nope. They're not similar. I mean, you could check the third one, but you already know if one of them's not, two of them don't work, then it can't be similar. Okay. Okay, you ready to try one on your own?
Yes, ma'am.
Yes? Okay, let's go over this. Some argument. How many people say yes, they're similar? Okay, almost everyone.
Yeah.
How many people say no, they're not? How many people are still not sure how to do this? Okay, so let's go over this. So can someone who got yes tell me how you checked it?
Oh, I know.
David?
You know the triangle that's upside down?
Uh-huh.
You see the triangle that's not upside down?
Uh-huh.
I just like looked that around like matching up.
Okay.
Pairing it up with each other.
So you just lined up this way?
Yeah.
Okay.
So I got 6 over 8 equals 6 over 8 equals 9 over 12. And then I was like, what's the least, like what's the number that can go into both of them? So I came out with 2 for 8 over 6.
Oh, no wonder I put
And then I got 3/4 for 6 over 8.
Okay.
And then like for 9, 12, I did 3. Like 3 times 3 is 9, so that was 3. And 3 times 4, which is the denominator. So I got 3/4.
So all of them are 3/4 then? Okay. Chloe, did you figure out what you did?
Yeah, I put 18.
Oh, okay. Now, I know some of you got 3 over 4, and then some of you got 4 over 3. So I just want to point out that it's okay if you switch them around. If you did this triangle over this triangle, as long as all these, for all your proportions, these sides are over those sides. So either way you do it, as long as you stay consistent. Okay?